In this video, we're going to look at informative advertising. Consumers can be informed in a variety of ways. The firm can inform consumers by providing advertising with informative content. It can use product demonstrations, or it could use trial versions or money-back guarantees. In the top image here, we have an example of an infomercial where there is a product demonstration. In the image, you see Vince demonstrating the slap chop, a device for chopping vegetables and other things. And he's showing how you use it, what you can do with it, and providing a lot of other information, including about how easy it is to clean. So this is an ad with directly informative content. In the bottom image, you see Norton Internet Security, and they provide a free 30-day trial. So you are able to try the product for 30 days without committing to purchase it, and this allows you to learn things about the product. A similar way to get information across is to provide a money-back guarantee, which allows you to buy the product without committing to purchase because you can return the product, say, within 30 days. And this 30 days allows you again to try the product and see how much you like it. In order to study the effect of informative advertising on things like a firm's profit and on welfare, we're going to look at a very simple model with one firm. And in this model, advertising is going to allow the consumer to learn whether they like the product or whether they don't like the product. We have a continuum of consumers of mass 1. Each consumer is called Connie. That's Connie in the picture. Her 5th birthday is coming up, and she's been given some money to buy a cake or not buy a cake. Each Connie has a willingness to pay for the cake that is either VL or VH. The higher valuation is VH, so this means Connie likes the cake. Whereas if her valuation is VL, that means Connie does not like the cake. VH and VL are both greater than or equal to 0, and VH is strictly more than VL. Lambda here is the proportion of Connies with a willingness to pay equal to VH. For each individual Connie, it is the probability that they like the cake. And 1 minus lambda is the proportion of Connies with a willingness to pay of VL. If Connie is uninformed about her willingness to pay, then she is willing to pay her expected valuation. Connie is a very smart, almost 5-year-old, so she knows how to calculate expected valuations. Her expected valuation V bar is equal to 1 minus lambda VL plus lambda VH. So to get the expected value, we just multiply along each branch and add them up. As an example, suppose that VL equals 2, VH equals 8, and lambda equals a half. Then V bar is just half times 2 plus half times 8, which is 5. So you can see that the expected valuation is somewhere between VL and VH. So a consumer that is uninformed is willing to pay something in between the two values they might have if they become informed about their willingness to pay. Now there's only one firm, or one cake stall, owned by Alice. Alice sells only one type of cake, and Alice chooses whether to advertise her cake or not. So she chooses a level of advertising of either 0 or 1. And then she chooses her price. So 0 here represents no advertising. Connie is uninformed. She is willing to pay her expected valuation. Whereas 1 represents perfectly informative advertising. Connie knows whether her valuation is VL or VH. Advertising in this model is costless, and there is also no cost of production. So we're going to look at each case, no advertising and advertising, find out the optimal prices and profit, and compare the profits from advertising and not advertising. So when there's no advertising, the cake is in the box. Connie does not know what it looks like or what it tastes like. Her willingness to pay is her expected valuation V bar, and so her demand is going to be 1 if the price is less than V bar, and 0 if the price is greater than V bar. So let's draw the demand curve and work out the optimal price and the maximum profit. When the price is more than V bar, Connie will not buy. Her demand is 0. When the price is less than or equal to V bar, she will buy. her demand is 1. So this is the demand curve without advertising, D0. Now what's the profit maximizing price? Well, there's only really one candidate here, and that's V bar. If Alice prices at V bar, she'll get a demand of 1. If she prices any higher, she gets a demand of 0. If she prices any lower, then she's giving up some revenue. So the optimal price here is V bar. So we'll denote the profit maximizing price by P0. The maximum profit is going to be the area under the demand curve there, pi naught. So all the Connies buy, and the maximum profit is V bar. In our example with the numbers, P naught was 5 and pi naught was also 5. These are both equal to V bar. So we can see that without advertising, Alice is able to extract all the surplus of all the consumers. Now what if Alice advertises? Then Connie can see the cake, she can taste the cake, she works out whether she likes the cake or whether she doesn't like the cake. Now a proportion lambda of the Connies will learn that the valuation is VH, and the proportion 1 minus lambda will learn that the valuation is VL. So their demand is given by the formula there, but it's easier if we just look at the picture. If the price is more than VH, then demand is going to be 0, because VH is the most that anyone is willing to pay. If the price is less than VL or equal to VL, then the demand will be 1. If the price is above VL but less than or equal to VH, then only the consumers with a high willingness to pay are going to buy. The proportion of consumers with a high willingness to pay is lambda. So this is the demand curve with advertising. Now what is the profit maximizing price? Now we have two candidates. The profit maximizing price is either VL, in which case all the consumers buy and profit is VL, or VH, in which case only the Connies who have a high valuation buy and profit is lambda times VH. So there's a choice between selling to all the consumers at a low price VL and selling just to the consumers with a high valuation VH. If the price is VL, then the profit is going to be the green area, whereas if the price is VH, then the profit is the blue area. And Alice will choose to price at the level that gives the highest profit. So she'll pick a price of VL if the green area is bigger than the blue area, and the price of VH if the blue area is bigger than the green area. So the maximum profit is pi 1, where pi 1 is equal to the maximum of VL and lambda VH. In our example, we had VL equal 2, VH equal 8, and lambda equal to 1/2. So pi 1 in that example is the maximum of 2, which is the profit from selling to everybody at a price of 2, and half of 8, where 8 is the price Alice would choose to sell to just the high valuation consumers, and half of the consumers are high valuation. So the maximum profit is the maximum of 2 and 4, which is 4. So in this example, it's best for Alice to price high and sell just to the high valuation consumers. This is because VH and lambda are sufficiently large. So now let's look at the question of whether Alice should advertise. So let's remember the profit from not advertising, pi naught, is equal to V bar. And V bar, remember, was 1 minus lambda VL plus lambda VH. The profit from advertising was pi 1, which was the maximum of VL and lambda VH. So we need to compare these two expressions to work out which one is largest. So let's look at the bottom expression here. Pi 1 is either equal to VL or lambda VH. So to show that pi 1 is less than pi naught, it would be enough to show that VL is less than pi naught and lambda VH is less than pi naught. So comparing the two expressions, pi naught here is equal to V bar, the expected value, and the expected valuation is more than the smaller of the two valuations, VL. So this is less than V bar. Lambda VH is also less than V bar because we have lambda VH here, and V bar also has this other term. So we have the same term here, but an extra term. And this term is positive as long as VL is greater than 0. and lambda is less than 1. So this is also less than v bar. So since both of these are less than v bar, pi 1 is less than v bar, which is equal to pi naught. So the conclusion is Alice should not advertise. So what's the idea? Well, when Alice does not advertise, she can effectively perfectly price discriminate. So let's think about a hypothetical case where once she's advertised, she's able to perfectly price discriminate. What profit would she get? Well, she would sell the cake at VL to those that are willing to pay VL, and she would sell the cake at VH to those who are willing to pay VH. How many consumers are willing to pay VL? Well, the proportion is 1 minus lambda. How many consumers are willing to pay VH? Well, that proportion is lambda. So the profit is the sum of these two terms, which is just the expected valuation. So the profit from informing consumers and then perfectly price discriminating is the same profit as not informing the consumers and pricing at their expected valuation. The area under the demand curve D0 is the same as the area under the demand curve D1. By advertising, Alice's demand curve now becomes downward sloping. It has 2 steps, and she's no longer able to extract the surplus with just one price. Whereas with demand curve D0, she can charge one price and extract all the surplus. Now this result generalizes to any number of valuations and also to continuous distributions. So what we found is that a monopoly may prefer to keep buyers ignorant in order to be able to effectively, perfectly price discriminate. What about welfare? Well, not advertising actually maximizes welfare because effectively the firm is perfectly price discriminating. However, consumer surplus is 0. Now, 2 reasons that advertising could improve welfare are advertising prevents those who value the good below marginal cost from buying. So far, we assumed that all consumers valued the product above marginal cost. So in the case we looked at, there's no role for advertising in screening out consumers who value the good below marginal cost. Another reason advertising might improve welfare is that advertising allows consumers to choose the product that gives them the highest surplus. But here we assume there's only one product, so consumers are only choosing between buying and not buying. Here we're going to look at the difference between this model and the model with quality. So in the quality case, for example in the burning money model, the firm knew the quality while consumers did not know the quality. So there was asymmetric information initially where the firm knew more. In the case of quality, advertising may indirectly inform consumers about quality, and that makes information symmetric, because after consumers are informed, if they all have the same willingness to pay, then the consumers know their willingness to pay and the firm knows their willingness to pay. Now, if it turns out the quality is high, then informing increases the valuations of all consumers, whereas if consumers learn that the quality is low, then it decreases the valuation of all consumers, because the expected valuation will be in between the high and the low qualities. On the other hand, in this model of informative advertising, firms and consumers initially only knew the distribution of valuations. So they both knew VL and VH, and they knew lambda. So the starting point was symmetric information. In the model of informative advertising, advertising informs consumers about their valuations, but the firm does not learn which consumers have which valuation. Information becomes asymmetric. And informing actually can decrease the valuation of some consumers. So those consumers with a true valuation VL have a reduction in what they're willing to pay from V bar to VL, whereas those who learn that the valuation is VH have an increase from V bar to VH. So the effect of advertising is different on different consumers. This is different to the case of quality. And so this explains why we can get quite different results. In our model of informative advertising, the firm did not want to advertise, whereas in the burning money model, they did want to advertise because that would increase everyone's willingness to pay and therefore increase the profit of the firm. Now let's look at the assumptions we've made in the model. So one of the assumptions was that the marginal cost of production was 0. What if the marginal cost of production was C and it was positive? Well, in the case where C is more than the expected willingness to pay, it will certainly pay for the firm to advertise, because if they don't advertise, they'll not be able to make a profit, because their price would have to be less than C in order to be able to sell to any of the consumers. It actually turns out that if we've got two valuations, it's going to pay for the firm to advertise as long as the cost is greater than the lower valuation. And this is because if the cost is greater than the lower valuation, but less than VH, then the firm will want to screen out the low valuation consumers and just sell to the high valuation consumers. And the only way it can do that is by informing the consumers about how much they value the product. Another thing we assumed was that the monopoly could choose only no information or perfect information, but it might be that consumers already have some information, and a monopoly may want to actually choose partial information, and we'll see that in the tutorial question. We assumed consumers are not able to search, so they couldn't go and find out information themselves. But if we allow search and the firm does not advertise, then consumers might choose to expend some effort finding out about a product, and this might affect the monopoly's choice about how much information to provide. Finally, we assume that consumers are risk neutral, so they were willing to pay their expected valuation. But if consumers are risk averse, then their willingness to pay will be less than their expected valuation. And so if consumers are sufficiently risk averse, their willingness to pay is sufficiently lower than the expected valuation, it may be profitable for the firm to advertise. In the extreme case where consumers are infinitely risk averse, so essentially they assume the worst, that they're only willing to pay VL, then the firm can always do at least as well as by informing as by not informing.